Okay, so welcome to DevHeads office hours for June 7th, 2024. And happy to be here. Here's our typical, our standard agenda. So today, AI and development, and we'll go through community questions. I actually didn't have time to get to today, so we'll skip that, but we'll go through everything else. All right, so who we are. I'm Brandon. I'm a tech journalist. I've been doing this for about 15 years, so happy to be here. I love the community, some of the people I've met, and some of the things I've learned along the way. Amesh, you want to go next?
Yeah, hello. So I'm Umesh. I've been building embedded software and hardware more than past 10 years now. So thank you.
Cool. Himal, how you doing, man?
All good. How are you guys? This is Himal. I'm a hardware engineer, and currently looking for some new projects to do on weekends or on my free time. So, yeah, if you guys have any idea, let me know.
I might have something for you. I'll talk to you offline.
Okay. Perfect.
Ming, how you doing?
Doing well. So I'm Ming. I've been a Unix consultant for coming up 30 years now. In terms of just looking at what some of the stuff I've played with on AI, did introduction to machine vision back in 1989 when we were looking at machine vision on analyzing a cookie manufacturing line to look for broken cookies.
Yeah.
So been hanging around AI for quite some time. My master's thesis was actually on character recognition in AI.
That's awesome. I have an Easter egg for you that's hidden in the slides, and I want to see if your head explodes when I get to that slide. Navadeep, how you doing? Camera's off, mic's off. Oh, mic's on. What's up, man?
Hey, bye. Doing good, doing good. Excited to see what's up with AI and to probably hear to some stories.
Sure. Actually, I pulled from your blog some of your observations about hardware design, and we'll get to those in a second.
Sure.
Moving right along. Okay, so here's the topic. We've already sort of introduced it. As I said, VLSI is sort of an obvious place. When you talk about millions or billions of transistors, that is a place where you would clearly want to try to apply anything that's going to give you some efficiencies. So a couple of years ago, year and a half ago now, I went to SNUG, which is Synopsys Users Group Conference. And at that point, they were really starting to integrate AI into a lot of their EDA tools. This is a blog from just before that, actually maybe 6 months before that, talking about where they were at that point. And this is identifying that it takes a couple of years maybe to design a chip and manufacture it at scale. In early 2020, Synopsys started playing around with the use of AI, and they're doing it now. Now, where they're doing it is essentially to help with, in their tools to help with design, design and verification and test. And they're hoping that the optimizations that they can get through the use of AI in these tools, and their users can get through these tools, are going to create optimizations in chips that net 1,000x up to 1,000x compute performance, which means that us humans have been leaving a lot on the table, I guess, in terms of chip optimization. But that's sort of an early stage place where an engineer would be using AI in their daily job, and that's what we want to focus on today. Now, here's the one for you. Oh, nope, it's the next one. So this is Navadeep, actually. Navadeep's blog, Yet Not Yet, Let's Give a Thought to Where AI Is on Hardware Design. And I'm going to be curious to hear what somebody like Himal has to think about or has to say about this. In Navadeep's blog, which is hosted on GitHub, he talked about, okay, we can use AI, but there are a lot of very, specific tasks that you do in the hardware design process. And are you comfortable with AI making some of those decisions in terms of placement, in terms of, you know, how you're going to go about your design cycle, right? Are you comfortable with it everywhere in the design cycle? And I want to hear what Navdeep has to say to expand on this in a little bit. But beyond that, oops, I forgot to change this header. But Ming, this is AI in an AI operating system. So for AI in an operating system, this is a bunch of suggestions on ways that it could improve the way that systems perform, you know, resource management and scheduling. Obviously, there would have to be things that were addressed in terms of privacy and security, but it could help optimize things like real-time processing at the edge. But most importantly, it's this adaptive behavior concept where the operating system could change along with its ambient environment potentially, and perform differently. Now, for those of us who've been in embedded, this seems like a far out concept that, you know, it's sort of like sci-fi stuff. But I don't know. I don't know if you think that this is just fool's gold, or if you have any thoughts on what that would potentially look like. But I'll ask you that here again in a second. These are the examples of ways that people are using AI today and thinking about potentially using it in the future. So I want to kick off now and just ask, before I go back into some of those questions that I posed, is anybody today currently using AI in their work, in their day-to-day job? Anybody on the call? Navdeep, do you use it at all? Do you find places in your hardware design?
Yeah, interesting, but yeah, see, I use the standard tools which are available. Like we have the OpenAI, the ChatGPT, or the Perplexity AI, which just makes you easy to find resources, or even with ChatGPT, right? You might be sometimes stuck in a place where it might be a simple thing in a code which you're not realizing where to flip the bit, or what exactly to do, or you might not be knowing the syntax of some new type of programming, or sort of script you want to do. At that point, instead of going through, one good habit is to go through the documentation of the whatever scripting it is, and read through and try to get it from there, or otherwise ask these type of tools, and then understand from there, taking that as a source point, understanding backtrack. Of course, this backtrack is quote unquote, and it's important to know where it comes from, and is how well it suits to what you are targeting to do. But yeah, these are pretty much what I use. I started liking Perplexity quite a lot these days, because I like the follow-up feature it has, right? Uh, if I just search in a web browser, gives me certain results. Then the follow-up will not take me in the it may or may not take me in the same direction as what the primary question is. But with this type of tool, I did not go to understand what is the underlying technology they have, but Publicity is quite interesting in just to satisfy the craving, if you want to uh, if you want to understand a topic and go deeper into it and further on. So it's to learn new things, and tools uh, like LLM based chat GPT and stuff like that, to on even chat GPT 4.0, which has come, which is a multi modal. It can also give you it can take image inputs, give image outputs, and take text inputs, process a document, and stuff like that. These are helpful in doing small, time-consuming jobs. Yeah, these are things which comes in daily work, but haven't actually ventured into any tools, or like a design tool set which uses AI in that. Probably I've heard about people talking, like Hemal just shared about Flux AI, right? So I'm quite bullish on these type of things, although there is a huge offset, or there is a huge barrier of confidence which a hardware designer has to build, or hardware designer has to get compatible with these tools. Okay? We humans make mistakes. It even passes to the review phase. So if the design is not made by a human, then the review phase, anyways, we are the human-made designs are the errors in human-made designs are passing to the review phase, knowing we have made the design. But in this, the probably we should double down on reviewing the designs, hardware designs, and make very sure these tools are right. So that
That's
confidence.
that's exactly what that's like. One of the big questions that I have is like, so you shared this, Navdeep, about the Circuit Mind, and then there was Quilter, and then Hemel's shared a couple of different tools over the last couple of months. It's like, if you're using this in a professional context, are you really just like committing yourself to extra review cycles here, right? I mean, it's not like you're going to not review this. And frankly, I think that if I were to say, like, use it in a way that the AI at any point is pretty much left to its own devices, right? It's completely, it's not here assisting you, but it is actually doing the work. I mean, you're going to have to check that. I'd assume you would check that just as much as if you were going to do the work yourself in the first place. Is that, would you say that would be true for you, Navdeep?
I'm afraid I will have to spend my design time plus review time on review time if AI does all the things.
Right,
So,
right. This design time plus review time becomes review time plus review time, right?
yeah. That's if I let it to do all the process. But where I am bullish on these with respect to hardware design is in places where it can help me in finding out the DRCs, help with the design rule checks, right? Help with electrical rule checks. Currently, it's the DRC for you say you are making a 16-layer RF board. The DRC is going to take, depending on the complexity, is going to take you a couple of weeks to find out, solve. If a tool something like this can group particular categories of DRCs and provide me a solution, or solve itself and say, hey, look, here is how I solved, and give me a log report, and that would help. So these type of places where it's a repetitive job for human, because these type of errors, right? You may get tens of similar type of errors in a design, although you know how to solve after you solve one, but you have to go through that rigorous process of solving a rest. So in these type of places, that can these tools can help. Is what I feel. But leaving it all on top of it, I'm not very sure. I cannot even imagine how that can work out. Unlike in writing a code and testing it out.
How about you, Hemel? Have you in hardware design, have you leveraged any of these tools? Here's a, besides the one you put in the chat, which is FluxAI and JetX, there's another one, Quilter, here that Navdeep shared in his blog.
Not yet. I'm keeping a very close eye on all of them. From my work, also they are encouraging if there is a way we can use AI in our workflow that could make any part of our process faster. But not yet. I remember there's also one more called CADY, CADY. So for me, LLMs, I just use GPT for some stuff and things like that. But for hardware development, no, not yet. Yeah. So this one, the one you shared previously, the Circuit Mind, I had a chat with him. I think Tomide is the name of the founder, and this helps you in the beginning of the review. Like when you're starting the design, it gives you like many different options of combinations of ICs and things like that. And this KD is something that helps you at the end of the design. So I think you just feed it a net list of your completed design of the schematic, and it tells you how is the sourcing going to be, if every part is voltage compatible and things like that, or if you have connected a 3-volt pin to a 5-volt pin and things like that. So that's what the KD does. So there are different ways where AI can fit into your workflow. And GTEx and Quilter and Flux AI, I haven't tried them like hands-on, but as far as I know, they are a better version of the auto routers. And I've never used auto router in like ever. So maybe these are more better auto routers. And the thing with auto routers is something like similar to how you set up your, let's say, a simulation of some sorts. Simulation is as good as how your initial conditions are, and if you don't get that right, your results are gonna be affected by that. So similarly, in GTEx, for example, you have to give all the constraints and things like that before you start the design. But if there is some issue in the constraints, or which you are not sure about, and then it will spit out a design that might not be the most optimal design. So uh, but I saw a demo of GTEx on Robert Varanik's video. He did like a live demo of sorts. So there was a very nice moment where the machine was trying to route some parts, and the host, he just told that you should just route it the other way. So at that point, I still felt like the human touch is still there, where the AI was not able to figure out the things. So GTEx is something that is something I'm kind of looking forward to. Maybe it will. So it's everything is code, and all these things are generated on its own. So you define your schematic in code. Your, I think, placement you do with the, and it's everything is browser based. It's I think it's a plugin in VS Code. So, but yeah, as of now, to give you the short answer, I'm not using currently any of the AI tools that are there, but maybe we'll find someone which is worth that really that does the job. So yeah.
What are typically the types of the hardware design? What are the applications you're designing for?
It's mostly like high speed stuff. So there are like high speed interfaces. So it could be Ethernet, it could be USB 3, USB 2, impedance control stuff. There are also some power management also that you have to take care of in those boards, because the power requirements are also a bit high, and you have to make sure of the noise levels are also within limits and things like that. So I think, yeah.
Would you be comfortable using one of these tools, and would you trust it, basically? So that's what Navadeep says here. So the trust barrier.
Yeah. So yeah, I'm not sure, unless it's the thing, like unless you try it, you cannot trust it blindly. So for sure we can I can do like a test run, make a small board, and if I see the results, then maybe if it makes any mistakes, then probably I could correct it. But yeah, as he said, you'll have to spend more time in the review and the setup and doing the things. But it is interesting. I'm sure I'm not saying they will never replace hardware engineers, that we will have our day as well. So I'm not sure when, but I'm sure it will be soon than later.
This is like Navadeep makes an awesome point here. Hardware design revision costs money, unlike recompiling and rebuilding. You know, I mean, I guess, I guess technically recompiling and rebuilding, you're paying somebody, but man, it's a different kind of mistake there, right? So that's a good point, Navadeep. Okay, so I wanna move back into this weird sort of like blow your mind kind of idea with an operating system that would essentially evolve a system, based on the intelligence there. Now, this is hugely problematic if you're doing anything that requires determinism, right? It just wouldn't work. Ming, can you wrap your head around this? Like what this AI operating system idea? And I don't mean as like a layer, right? I don't mean it as like in the code.
I mean, I can see immediately some uses. For example, having an AI-based IP tables to dynamically reconfigure your security based upon what's going on. But to do something like, dynamically changing the scheduler or something like that, I would be interesting to see what the concepts behind something like that would be. Whereby if you've got your system, because I know that when I'm trying to build and look after a system, I want to know what the scheduler is, because I'm trying to tune everything for what I know my workload is going to be. And to then have that taken away from me, I'd be a little bit hesitant. Again, coming back to the trust aspect of having designed the system for a particular job, I think I know what it's meant to be doing.
Right. Which, this is that whole, Rise of the Robot Overlords kind of thing, where I can totally understand why, if you have an edge system, so set and forget, we're going to throw this way out into the, boonies, and it's going to need to essentially run by itself. It says even here, like this is a Medium blog by a gentleman, Theo Priestley. And when I upload this into the notes, I'll put the links to all of these blogs in there for everybody to review. But if you have an IoT system that's out in the wild, it even says in here somewhere, autonomous operation and self-healing, this is perfect, right? Yeah, of course. We're deploying this thing out there. It's going to be 5 years, from now. We don't have to send somebody out there. It'll take care of itself, at least to some extent. But then what you get in exchange for that is essentially a system that you don't know what it is anymore, or what it's doing.
I would go for that, especially because, amusingly enough, I'm actually just in the process of one of the projects I'm looking at is for a self-healing network reconnection system. And yeah, for that, it would be interesting to try and look at it with an AI aspect, as opposed to, I have determined all the possible modes of failure and what the recovery aspects are for each of those modes of failure. If you were to do a self-learning, machine learning type of thing there, I think that'd be a long way out, because the machine itself has got to work out how to fix itself.
And I don't know anybody who's going to, any company that is going to deploy that. Why would any company? What's the commercial use case behind it? That's the real where the rubber meets the road, right? That's why it's interesting to ask Navdeep, yourself, Hamal, do you trust this thing? Because at that point, when a commercial endeavor, when an enterprise decides that it will trust something, that it will trust it enough not only to use it but to pay for it, right? That's the sniff test. And here, this is so far out. This is wildly far out to me. That it's borderline, like I said, science fiction. So, anyway, as anybody else here, has anybody else on the call used AI in work beyond ChatGPT? Let's talk about anything that's not ChatGPT related. Any use anywhere by anybody? Nope. Well, I'll let you in on something that we've been working on. So we're actually using LLMs right now to try to look at different types of products, and if different types of products can be presented based on what a user needs, right? Presented and contextualized using an LLM that is scanning information about that product. That could be an application where I could see, it's not necessarily in your hands-on day-to-day, using this as a tool to build something, but it's in the workflow. That being an application, an early stage application. And when Christoph was talking about this, I was like, okay, as an IDE, I can see how you could potentially use a large language model to give recommendations, right? To suggest things, potentially. I don't know how far down the rabbit hole he was thinking about going with that, Vermbeetle, but it's certainly an interesting concept, and one that I'll be interested to hear from him when we're able to touch base with him again. All right. Anybody have anything else? Say, Umesh, how about you? Any thoughts of using AI in any of your upcoming projects?
So I have a, unfortunately I'm not using that much, but yeah, I mean, as far as everybody else, what they said, like as an assistant, I'm happy to use it. But I have some ideas of my own, because as a developer, everybody has some expectations. Like somebody says for the hardware, like people are saying, okay, some hardware design tools are pretty much like a mature auto routers, right? So how I see the embedded software and hardware ecosystem is like, because auto router existed from the beginning, right? It's more than decades, and now they are evolving in a way that the modern, design tools, AI based design tool, can able to make that more efficiently. So similarly, in the development in the embedded software space, I see the auto completion feature will get better, improved. So maybe it would scan all, functions or methods or something throughout the libraries or drivers or something. But one thing I have heard about it with one of a discussion with pretty solid experts here in India, is a code base aware interaction. So I would like to know if anybody of you have heard about it, code base aware interaction, because we write a code in the development environment, and then we have a suggestions coming up as an, and then we as a developer understand that feature as the auto completion feature, right? But more than auto completion, it would it would give us a suggestion in a way that we will interact with it. We can ask questions on the top of suggestions. I hope you're getting. Now we are interacting with the suggestions that what we are getting. So something of that sort, if come up in the IDE, I believe that would be a game changer.
Yeah.
uh, and I'm looking forward to hear if somebody have seen such a tool, so that I can try in case if I.
So
Yeah.
so let me clarify. So you're basically saying that you interact, you have an input, and essentially you get an output from what amounts to a chatbot, right? Or something similar, right? And then you continue interacting with the output, right? So that you're now interacting with the output repeatedly, right? Is that what you're saying? And
Yes.
refining continuously.
Yes.
Okay.
So we are basically talking like an agent. So in the IDE, you have a development agent, and now we are asking him, okay, you are giving me suggestions, but what if this is the case? If that is the case, right? Now you are checking different conditions right here, and that agent is training itself. I mean, this is just what I have heard about it, but I think this looks promising than just an auto completion feature. So we have to see how it's developed, but yeah. So
So
that's
this
what I
is
think they call. Sorry.
no, sorry. So one of the important things to understand here is, especially if you're talking about large language models, is LLMs. Like Hemel has this here, which is a good point, which is um, that there's a lack of trust because AI works with probabilities and it's not deterministic. And the reason for that is that the way that in an LLM it works is you take chunks, right? You take a chunk of your data set and you analyze that chunk, and then you determine what the probability of accuracy is based on that subset, right? So what you're talking about, there's two ways of looking at it. Firstly, it's hard for me to wrap my head around something, because if you're talking about like something that's so open, right? Like programming in C. I mean, this isn't like a restricted data set where you can say, here's a beginning, here's an end, and we're just analyzing everything in between. So that's on the one hand. But on the other hand, the good part is if you could structure the data set in a way that would make sense, is that as you continue to refine, right, the chunks get smaller and smaller, right? And so your probability of accuracy is going up just because there's a smaller and smaller data set. So that could be really interesting if you could find a way to. I'm trying to think of how you would even
I think
do this.
some of the IDEs probably for front end development are trying it. I haven't seen it in the embedded space, but I think some people are trying. That's where this discussion came up when I was having this discussion. So, but there is a big problem of it, like a copyright issue. So let's say somebody write a code and then it will pull up from somebody else's method or the functions and APIs. Then there are a lot of things, but it makes a sense for, let's say you are a company, big department, and you have your own developer. 50 developers are working on one very complex code base, and now agent is learning on the top of your 50 engineers behavior. Now let's say if you're writing a drivers for UART, and now you are assigning the variable, now the agent is learning behind what is the size of your data, right? What frame size, let's say you are reading from energy meter, the frame, then it understands in what context, and then it will go more finer and finer, training its model. I mean, this is just my thought. I'm not a compiler developer or somebody like that, but maybe if that is where it reach, then I think it would make a lot of sense that we would say, okay, that's a real AI.
Well, so Navadeep mentioned perplexity really quickly, and you brought up something that was, so firstly, the copyright issues, right? I mean, here's a clear use case of perplexity, right? Okay, if we can have that plug in and just give us the source of where this came from, that might even help with some of the some of the bomb checking, right? That's really interesting. So yeah, I mean, this is a quality of LM. Yeah, this is an interesting area. Ming, you brought up the paperclip, Clippy.
Just the whole thing of there was the old equivalent of the Copilot of Microsoft trying to do some kind of semi-intelligent assistant, which I'm glad that it didn't have that interactive feature. Otherwise, I'd have been teaching it a whole bunch of really bad language.
Yeah, no, for sure.
No, I don't want you to help. Go away.
Right. Yeah. No, seriously. But it's actually, I think when you tell us about how you were working on your thesis and you were doing some of this OCR stuff back in the 80s and 90s, it's like a lot of us, I at least, forget that there's a long arc of this technology, right? And it's not just all of a sudden, oh, boom, we had OpenAI, and then all of a sudden, the dawn, right? When you mentioned Clippy, it's like people have been trying this for things like this, fusing different technologies and concepts now, but for quite some time.
They have. I mean, one of the standard jokes when I was playing around and more involved in AI was, well, it's 10 years away from. Now, it's been 10 years away from whatever it is that we're trying to achieve for the past 30 years. It's always going to be, in 10 years, we'll have sorted this bit out and it'll all just be magic and work.
Yeah.
But there is a long arc of development in all of the things that are going on. And what I'm seeing is that the big push recently, where AI has happened so quickly, has been the improvement in processing capability. Because having looked at, there's very little difference between what the AI techniques are now as they were 20 years ago. We can just do them faster and at larger scale. And if you're saying about being able to improve the compute power by another 1,000 times, what is that going to give us in terms of improvement on being able to do more at scale?
Yeah, and it works very well to apply this in the context of chip design, because like it was mentioned earlier, this is probabilities. Well, a chip design is not very, it doesn't have a lot of variation in it, right? So it's easier to apply there. But yeah, hopefully in the next few years we can start leveraging some of the advances there and figuring out ways that we can apply more of the math part. If we have processors that are capable of doing more math, you can start, relying less on statistics and guessing and more on math, hopefully.
There is a standard joke, because I did all of my AI research in a maths department, and the standard joke was, if you've got a particular method and it converges quickly, that's a mathematical method. If it takes a couple of days, that's AI.
That's awesome. That's awesome. Cool. I'm gonna play this this thing of this guy who invented Clippy. Thanks, Emil. And then unless we have anything else, we can shut it down for today. Let's see. Here we go. This is the man who created Clippy, who, according to Navadeep, looks like Ming. Not that man.
What is this? What is this thing? What? Why is it doing this? I just want to write my letter. What are these options? Oh, dang it! How do I get rid of... What? Ah! Who invented this stupid paperclip?
That'd be me. My name is Kevin Atterbury, and I write and illustrate books for children. Back in the 90s, I had a graphic design company, got to do a little bit of work for Microsoft, and I was asked to design some characters for a project called Microsoft Bob, which may be one of their biggest failures. It was software for people having their first computer experience. They liked the idea of these characters that could tell what you were trying to do and offer their assistance. After the failure of Microsoft Bob, they ported the character technology over to Microsoft Office. We went through 260 character designs to get down to the 10 that shipped for the product. Coming up with Clippy was not as big of stretches as you might think. And while it's obviously an Office thing, I love the simplicity of a paperclip as a character. I love the flexibility, all the things I could do. I love the fact that I was just using eyes, because eyes can't express it, and it simplifies my work too, right? I think I designed about 20 or 22 characters. I had a stapler, I had a stubby little pencil, I had a coffee mug. I'd do a lot of sketches, just hundreds of sketches. Once I got to where I liked it, I would scan it in, then start.
All right. Well, he's this guy's a sketch artist, so I was thinking
sorry,
that
my
he
bad. My bad.
I was waiting for him to be like, and then
that,
I invented the first chatbot. No worries, dude. Okay, cool. Well, let's see here. Let's get through. Does anybody have anything that they want or need from the community, or that they'd be interested in giving to the community? Any asks or gets? I'm going to skip this for this week. Anybody? I'm going to reach out to you, Hemel. I've got something that we may be able to work on together. So I'll let you know.
Sure.
Great. And then I skipped one of these. So we've got another engineering hour coming up on Sunday. Imesh, do you want to fill us in on what we're going to be doing then?
Yes, so this weekend on engineering hours, we will be exploring SPI communication protocol. So if you're in embedded, then probably you are already heard about it. SPI, very, very popular serial communication protocol. So we will be interfacing and developing drivers for a dot matrix display. So if anybody who wants to learn, understand, or maybe refresh the concept, maybe they could join us to the engineering hours. Thank you.
Great. A week from this coming Sunday, so that would be the 16th, we're actually going to have a new presenter in engineering hours going to help out Imesh a little bit. His name's Edison, and we're going to be looking at DMA, so direct memory access, for those of you who are uninitiated. And that is going to be the beginning of getting us really down into some task management type stuff. So we're going to go in from direct memory access into timers and going through timing, and then controlling some onto peripherals. From there, we're going to look at task management and then get into interrupts, and then that will lead us into the world of operating systems. So anyway, that's the path. So stay tuned, and Other than that, thanks for your grain of sand, guys. I'm always happy to be able to spend an hour with you guys on a Friday morning, Friday afternoon for some of you, Friday evening for some of you. So until next time, appreciate it. See you in the server.